Okay, so let's move on to talking about the natural number e. The natural number e is approximately 2.718. It's called Euler's number, and that's why it's called e. If you go into your textbook, you'll see there's a limiting function that actually generates a natural number e. And so it is self-generating and it naturally occurs. That's why it's called the natural number. But the important thing about e, don't forget, is this. This is what makes it really special. If y is equal to e to the power of x, then y dash is also equal to e to the power of x. That's the only function where that happens, and it has a great number of good properties for us moving into calculus. But we're not here to do calculus, we're here just to sketch functions. So given that e is 2.718, if I wanted to sketch this function here, well, that wouldn't be too hard. I just have to deal with an irrational number as part of the process. If I wanted to do it the way that we did at the end of the last video, where we talked about doing transformations, I could do that, but I'm actually just going to go through that process of y and x intercepts. I know I've got an asymptote at 1, and I know my function is not stretched, is not flipped. So therefore, I don't have an x-intercept. And I've just saved myself some time. No x-intercept, easy peasy. What I do need to do is just make sure I work out what my y-intercept is, and I need to recognise that that's a negative and therefore it's flipped over the vertical axis. So my y-intercept occurs when x equals 0, and I get y is equal to 2e to the power of negative a half times 0 plus 1, and e to the power of 0 is just 1, so that gives me 3. So we've got y-intercept of 3, no x-intercept, and it's been reflected over. It feels a little bit like there's maybe not enough information, so I might just make sure that I've got enough information by just creating one other point, perhaps when x is equal to 2, for example. If I put x equals 2 in there, it will cancel out that half. So at x equals 2, I get y is equal to 2e to the negative 1 plus 1, which is equal to 2 over e plus 1. And I can do that calculation really quickly. And I get that this is equal to 1.736. That's been rounded, of course. And so I can mark that point 2. At x equals 2, I get 1.736. That just gives me the scale, which is nice to have. And there's my function. Obviously it goes off in both directions, so I should have an arrow there. And this is something I haven't done yet this lesson, but I should also have y and x on my axes. So that's how we sketch an exponential function. And a really good way to do it is to set up your x and y intercepts and make sure you know where your asymptote is, and you're in a really good place. And example 7 is a solve example. I just wanted to show you this quickly on a calculator because this might really help. This is something that could come up potentially in a tech active exam. Because you've got an exponential is equal to a linear function, it is unsolvable. Okay, so here's my calculator. If you go into your calculator and go to graph, you can do lots of really good things in graph, including sketching the graph that's shown there. So I'll just go quickly back to here, e to the 3x minus 1 and 2x plus 21. Let's go back to here and sketch those. The first one is, and I might actually just show you this. So if I want to deselect y1 and deselect y2, I can do that just by pressing F1 while I'm hovered over them. And then I'll sketch them in here. E to the power of 3x minus 1, I might have to check that because I believe that was it. Yep. And that's selected. You can see that the green equal sign has been highlighted. And the second one is 2x minus 21, and I'm definitely going to check that, plus 21. So I'll just go back and fix that. So just make sure you're accurate. And then I can press enter there. They're both selected and I can draw that. Now I've got a syntax error because I've been using X on my keyboard. So obviously this is not an issue for you, but it is an issue for me. I'm just going to go back and fix that. So it's Shift E to the power of 3x minus 1. So we just need to make sure that you're using the actual variable E and the variable X. So this one will be 2x, there's my variable button, plus 21, and it will like it more. And press enter there, and then I'm going to draw that. So that draws my two functions. Now that 2x plus 21 isn't there. So I've got to be careful here. Obviously plus 21 means there's a y-intercept of 21. So I'm just going to update my v window. I want my x minimum to be -1 to 5. I'm happy with that. But I want to change my y values. Oops, so I'll just go back here. So I'll move down to y. -4 I'm happy with, but I just have to go a bit higher. So I'm going to make it go up to about 50. We'll see what happens. And then I'll draw that again. That's F6. And you can see now we've got that point where it meets. So we can solve by finding the point where it meets. So I'm going to go G-solve, and I'm going to find a point of intersection. There's lots of stuff you can do here. Roots is where the x-intercepts are. You can actually find integrals and things like that you'll see soon. But intersection point, there's my intersection point at 1.39 and 23.78. But the answer is x equals 1.39 is the solution. So I'll go back to here, and I can do from my graphics calculator that x is equal to 1.39. Now, alternatively, you can also, obviously, and this moves away from graphing, but you could go back to your main menu and you could solve in the equation solver in here. It's not a polynomial, it's not simultaneous, so you're going to F3, which is the solver, and then you put the function into here. 3, so E, and I've got to use the E in here, so shift E to the power of 3x minus 1, and that's equal to, and then I've got 2x plus 21, and I press execute. The first time I press execute, it just gives me my E without actually presenting to me the solution, my x without the solution. But now if I press solve, it will give me that solution. The only thing I'd say here is it's really important to recognize computability. You've got a calculator, it's very good, but the power of the calculator can be limited. If you've got a really complex function, but you know there's an answer somewhere between 0 and 10, you could change your bounds to be between 0 and 10, and it'll actually make your calculator work much quicker. And then solve, and it gives me my answer there of 1.39, and it tells me what the left is equal to and what the right is equal to when x is 1.39, which you'll notice here, that's the coordinate we got from the graph. There's a couple of ways to solve those equations, which I'm sure that you're already aware of. So there's example 7, and you could solve a function like that graphically, which I've just done on the calculator, and you may have to sketch things as part of that process though.